Test. All right, everyone. Hello. If everyone can join me at the front, that would be fantastic. If you can take a seat at the chairs. So again, everyone, if you can join us at the front so we can start in 35 seconds, that would be fantastic.
Do you feel like
All right, just again, if everyone could take a seat, that would be fantastic. At the front, that would be great if everyone could take a seat. All right, everyone. Hello. Now, wow, we've made it to the end. It is Sunday. We are going to present. We're going to show off what we've worked on all weekend to our
chin. Believe me, we come by, we wipe it off between as many presentations as we want. You're not going to be spitting on it. It's fine. You're not going to get sick from it sitting on your chin. You're not physically putting it in your mouth. Everybody cool? If you can hear yourself like this, well, I can't hear as loud as you can right now, but believe me, you'll be able to hear it. Nonetheless, good luck, everybody, and seriously, well done this year.
Testing. There we go. Awesome. So, for those of you wondering, what the order? How are we going to do this? And what I have no idea what James just said because that made no grammatical sense whatsoever. I'm going to read through the order first of all of the presentations, just so that you know what. Test. Check. 1, 2. There we go. All right. So what we're going to do as well, in case you don't remember this order for whatever reason, is we will always say who is on deck. Okay? So that means not you won't be next, but you'll be the next person after the person who's about to present. So that way you can get prepared in whatever way you need to. So start of the order, and the judges will note that this first person will be floated up to the top is Undercloud. The second team will be Air Care. The third team, ASON. Fourth team will be Citizen Can. Fifth team will be Crawl Space. 6 will be Drop the Drought. We'll then have a break to make sure that everyone has the opportunity to use the restroom, get a new drink, whatever else. And then we'll come back. We'll have JK Studios, Lark Data, Pinball Blizzard, Sustain City, Well Loved, Yams, and Yes I Can will be the last but not least team. Is anyone missing from this list? Fantastic. All right, so first and foremost, if Undercloud can start getting ready, Air Care will be on deck. What I'm going to do as well is make sure that we remember that this event, first of all, wouldn't have come together without you coming, taking the time out of your weekends to be here. So what we also want to make sure we have is the realization that this year is the first year, and I can't express this enough, where we have had all of our meals sponsored. We've had so many other things given to us and opportunities made available to us through this event, and I really want to make sure we take the time to thank our sponsors. So if we can get the sponsor slide up. The first person I do want to thank, the first sponsor I want to thank is TWG. They have done a fantastic job not only allowing us to be in this space, but making sure that we had internet throughout the entire weekend. That's a huge round of applause. They have been nothing but amazing and welcoming of us and making sure that we have everything that we need. And so we're very grateful to have them. We're also grateful for the City of Toronto and Startup Here Toronto for sponsoring us again for the second year. We had Symbility Intersect, which we hosted our event for the past 2 years. We're very grateful for their support again. XE came out again for the second year for us, and we're very grateful to have them. And of course, the DMZ, which again, if anyone has been in the tech scene in Toronto, you know of the DMZ and all the amazing work that they do. We also have a second tier of sponsors in the next slide that is Dot Space, Lighthouse Labs, and Fuse, and we're grateful for all of them. So can you give all of our sponsors a big round of applause? We also have our community supporters who have given us all sorts of opportunities to use everything from Amazon credits to access their data. We've had people supporting this event from January and December when Oksana, myself, and Kevin started planning the event, and we're very grateful for them as well. So can we give our community supporters a great big round of applause? Perfect. Now I would like to introduce our judges who are here today taking time out of their weekends away from family, away from friends, just like you did, but also are so excited to see what you've built, give you some feedback, ask some questions, and also hear some of your stories later on today. So the first person I am going to introduce is Marianne. Marianne, do you want to raise your hand? So, sure, let's give her a round of applause. So Dr. Marianne Mader is the Managing Director of the Centers for Earth and Space, Fossils and Evolution at the Royal Ontario Museum. She's a visiting lecturer at the International Space University as a co-founder of STEAM Labs and All Ages Community Makerspace. She has dedicated her career to sharing her love for space exploration through planetary science research, innovative public engagement, participatory education, and science communication. With over 13 years of field experience, Marianne has studied some of the oldest rocks on Earth in Greenland, explored impact craters across the globe, and collected meteorites in Antarctica. She has collaborated with the University of Western Ontario's Centre for Planetary Science and Exploration, CSA, NASA, and MDA to plan and execute simulated lunar and planetary exploration missions. Can we give Dr. Marianne Mader a big round of applause? Next up is Chris Mudd. Chris, you want to give your hello? Chris is the Director of Operations at TWG. His role serves three mandates: to make TWG Studio the best place in the world to work, find and keep the most talented people, and ensure the way his team works continues to evolve and lead their industry. Chris was born in Sri Lanka and immigrated to Canada as a refugee when he was 5. Chris attended the University of Toronto, where he studied philosophy, architecture, English, and French. Chris has always loved technology and was lucky enough to be surrounded by it even when he was young. He built his first website when he was 11, used CSS for the first time when he was 13. Can we get a big round of applause for Chris Mudd? Next up is Laith. He is the Investor Relations and Startup Services Lead at DMZ. Can we give a round of applause for Laith? Laith started his career as a trade finance relationship manager at a bank in Jordan, doing research and analysis on the bank's entire portfolio across 13 countries in the MENA region. 2 years after banking, he left to continue his graduate studies at the University of Edinburgh in Scotland, where he did his thesis on entrepreneurship and innovation, basing it on an accelerator in Jordan, Oasis 500. Laith holds a Bachelor in Business Administration from the American University of Beirut, as well as a Master of Science in the International Business and Emerging Markets from the University of Edinburgh. In his role at DMZ, Laith works very closely with startups, coaching and mentoring them, helping them develop their business and financial models, as well as preparing them to pitch for investment. Can you give a big round of applause for Laith? And last but certainly not least, Sunil. Sunil, if you can give a quick hello to everyone. Sunil is the managing partner of Extreme Accelerator and advisor of Earthcast and a hyper-connected venture capitalist in the Toronto-Waterloo corridor. Sunil was a co-founder of Extreme Startups, one of Canada's leading technology accelerators, backed by 5 of Canada's best venture capital funds. Sunil has co-led investments into more than 18 companies. Sunil is very active in the tech ecosystem across Canada, and particularly in the Toronto-Waterloo corridor, where he serves as EIR at Communitech. Sunil is co-director of the Founder Institute, the world's most global accelerator program. Can we give Sunil a big round of applause? Perfect. So, ladies and gentlemen, what is going to happen now? Undercloud's going to come up. They're going to hook up. As soon as they're ready, they'll give me a thumbs up. I'm going to be putting a timer on for 5 minutes. Again, this will be the same timer that I put on for everyone else. I'll give you a heads up when there's a minute left by going like this. When there's 30 seconds left, I'll do something like this. When there's 15 seconds left, I'll likely stand up. When there's 0 seconds left, I'll likely start berating you. Just over and over with awful, awful jokes. And that's how we're going to do it. Followed by that, there will be 2 minutes of questions from the judges. And again, there will be a timer set for that, just to keep us moving along. Any questions before we begin? Fantastic. Can everyone give a big round of applause for Undercloud? Cool.
Hello everyone, we are Undercloud. So we are so happy to be here to present our ideas with you. Let me introduce our team members, Clive, Angelo, Jingyi, and we have 2 remote members, Jason and Tianwei. So we are working on the Pilot Plus challenge, and I will go through all this contents with you today. And this challenge is about allowing pilots and passengers to identify geographic, natural, and cultural locations of interest along the flight path. So the first step we did was user research. So our target users was passengers. We did have a talk with the organizers about changing the target users to passengers, not only on private flights, but also public flights. The methodology we took was user interview and discussions, as all of us used to be a passenger on the flight. So there are some interesting findings. First one, users are interested to know the nature and history of the land and they pass by, and they also want to keep track of the flight status. But one concern they have is that it needs a large amount of data, and Wi-Fi is really expensive on the flight. And they also mentioned that if we're just showing them images and text, it's so boring, they'd rather watch a movie. So based on all these findings, our solution is to design an in-flight interactive learning system based on the existing device on the flight. Let me introduce Undercloud to you. So this is a snapshot of design requirements. We did a whiteboard section. So the features we have: real-time, real location, multiple choices of nature, history, culture, and news. That means compared to some existing apps on the App Store, we are not only doing geographical features, we also introduce the history, some interesting events, as well as the culture and news happening in the real, based on the real time and real location. We're also doing some data visualization and Interact 360 view of places of interest. So I will show you a quick prototype. Imagine we are doing a flight from Paris to Istanbul, so I depart. Then they will give a snapshot of the flight line to me. And then I would go inside the product itself. There are many choices: nature, food, history, and culture. So if I want to see things about culture, I click in the culture, and I go inside the product itself. So you can see all the sections here again, and I have animals, trees, and resources here. And all this data will be updated based on real-time, real location. As this is only a prototype, so it's not interactive now. So I can also click in tourists, and you can see now you have Colosseum and Florence Cathedral, as the flight now is near Italy. I can even click into Colosseum and have a 360 view of the Colosseum itself. So this is the end of the prototype, and I'm going to let Angelo to introduce the live demo.
Thank you. So So as you've seen in the prototype, the user will be greeted with a cards-based page. Clicking on one of them will then bring them to the maps page, where they will be able to see their flight path. And in the map, they can also click on points of interest and find more information about those points. Now, due to time constraints, we weren't able to include some of the features like a nav bar and a 360 view. So that will be in the next version, as well as a feature to save the map. And now Clive will talk about the marketing strategy for this project.
Perfect, thank you. So part of the problem for our product is the cost sensitivity of airlines. If we wish to license our product to airlines, major airlines such as Air Canada and Emirates Airlines will have to increase the cost per customer. A way to get around that is to prove our concept of a product. So the way we intend to prove our concept and prove our product is to actually introduce it to the App Store and introduce a simple function, a simple walking method of introducing it to the App Store. The way we are unique to most other competitors is that we have a personal aspect to our product. We provide nature, we provide culture, and we also provide geography, a combination of major competitors such as Google Maps. Thank you very much, and this has been Undercloud.
All right, we'll now welcome 2 minutes of questions from the judges.
So that was, pretty well done. Kind of ended a little abruptly for me. I was expecting a little more, but I know these are tight pitches. I kind of think one play here is to replace the in-flight magazine with this type of rich content. So when you think about the magazine experience, like the airlines know what the major routes are. So if you're flying Toronto, London, Frankfurt, we're talking about restaurants and attractions and city, people and just history. And so this is actually a very interesting way to augment that with real-time data, with studying border conflicts or some really interesting cultural significance to what you're flying over. And so maybe that would result, the revenue model of those magazines, I think, could be what you go after to make this a valid business proposition. So you can get the airline on board, city tourism agencies that can sort of appreciate that there's going to be potentially some sort of really powerful experience that people are flying on routes, children, adults. So I think there's something to it. I just think you have a lot more work to do, obviously, to make it real.
So part of our problem with the actual implementation of this in airlines is that the cost sensitivity of airlines is actually a big factor to them. A lot of airlines are creating an example of this would be where airlines made first class into business class and reduced the actual the seat size. A lot of airlines are reducing their costs right now, and we want to actually prove this product improves revenue for those airlines. So as you said, this would work extremely well in replacement of those magazines, as we can also provide products for in addition to the in-flight system. Yes.
Great. I have a quick question. One of the advantages of being above the clouds is everyone loves looking out the window, right? And that vantage point. And I'm curious what data sets, what NASA data sets or Earth observation data sets you're incorporating into this that allow that capability.
So we're going to be mostly using APIs that are out there. We plan to possibly build our own so that it will be a lot easier to pull data from, say, the Ontario website or the NASA website and stuff like that.
Cool. Can everyone give a big round of applause for Undercloud? All right, next up is going to be the team from AirCare. The team afterwards was ASAN. Unfortunately, they have someone who's traveling in that is running a little bit behind. So if I can have Citizen Can be on deck next, that is Citizen Can be on deck next. So next up is Air Care, and then Citizen Can will be after that. While the folks at Air Care get set up, I have one of my jokes. You love it. You're terrible. What is a spaceman's favorite chocolate? Okay, it's a Mars bar, I know. Why? Are you ready? Okay, I'm gonna do one more. Why did the sun go to school? To get brighter. All right, give a warm round of applause to the folks at Air Care.
Hey everyone, my name is Jeff and this is Bhavesh, and we are the team from Air Care. And the goal of our Space Apps challenge here was to link air pollution to the socioeconomic burden. The whole idea we got here was we were trying to figure out a way to link air pollution, and everyone knows the negative impact of air pollution, but we were trying to find a way to link it to the money that goes in the economy. And so we focused on air pollution and how it affects health, and how the health itself would affect the GDP of a country, the money that's needed for healthcare, for pharmaceuticals and whatnot. So we do have the benefits of industrialization and urbanization, but we want to see how it affects us negatively as well. So in order to characterize that, we focused on a particular type of air pollution, which is called PM 2.5, which is particulate matter of about 2.5 micrometers in size. And the reason we chose this in particular is because it's been linked to a lot of respiratory illnesses. And these type of particles come up from air pollution and industrialization. So an increase in these type of particles, it shifts the ecological balance of the Earth, which directly affects human health. So how did we characterize this, I guess? We first went to Health Canada as well as Stats Canada and tracked the increase in hospital visits due to respiratory diseases, most specifically asthma and rhinitis, which is inflammation of the nose, and the airways linked to it, as well as look at all the type of drugs that have increased in expenditure because of such diseases. Next, we tried to extract the data for particulate matter all across Canada. And then we're going to try and link this using a platform so it's easily available to industrial leaders as well as policymakers and see how it negatively air pollution negatively affects the GDP of your country. And I give it to my friend here to talk about how we did that.
Okay, so our idea here is it's basically a lot of data science and visualization, right? So we bring in data about particulate matter 2.5, which is, there's two ways of collecting it. One is using ground stations, and one is using satellite data. So the ground stations are pretty sparse. They're just randomly placed, and it depends on the country and their air surveillance program, how well they're placing this. So for example, China probably, I think, has, I'm not going to make any assumptions, but yeah, Canada's stations are pretty sparse. So if we actually want to get very accurate data, we would use satellite readings of the reflectance at certain frequencies or certain wavelengths of light. And then we're comparing that directly to healthcare expenditure. Now some of the issues we had here, like the data are very different, right? We're getting from different sources. It turns out that the granularity and the accuracy of the data we can get from the space industry is much, much higher in this specific case than from the health industry. So for example, for expenditure on drugs and on asthma-related cases, we just have it on a per year basis, or maybe once every 2 years basis, and only split up by province. Whereas if you're looking at particulate matter data, we have every single pixel represents 60 meters square of land area of planet Earth, and we can look at that, once a month or something. So these are some of the challenges we faced. Let me just kind of show you what kind of data we're looking at over here. Oh, whoops. How do I do that? Right, so this is asthma data. This is what it looks like. So the best we can get is it's the year 2012. This is the total amount of money that the economy spent on drugs. Okay, we have a minute. Okay. And then respiratory drug spending, patients with respiratory illnesses, and then we just kind of have to make magical calculations to, figure out anything more from that. And then on the other side, okay. And this particulate matter 2.5. So we have by the type of land resources, we have maximums and means. We actually have a lot more data, but I'm not showing here per month, per province. So anyway, we try to kludge it all together in this application using Python. Whole bunch of code over here. Let me try to run it, see if it works. Okay, air care, let's go. Ta-da! Okay, it doesn't work. We tried. That's yeah, thank you very much.
All right, 2 minutes, judges, for questions.
Well, we did see a correlation. I mean, we tried to plot the data in Excel to see, okay, yes, was there a correlation? And there was. There was an increase in the amount of drugs that were bought for respiratory diseases, as well as the number of patients in the various provinces. We weren't able to plot it here, but we did see a correlation.
Any last questions? Oh.
So I just wanted to ask, who do you envision as the beneficiary of these data, these plots, these visualizations, all that sort of stuff? Who is your target customer in a sense? But yeah.
World leaders, policymakers. I mean, at the end of the day, it's the industries that lead the country, and if somehow we can provide a visual depiction on how what they're doing, what industry is doing, or what a country is doing to negatively impact the health, can be changed because of our depictions, that's our target. I mean, yes, we can gain a lot from industrialization, but we got to show the negatives and somehow make it more streamlined so that we work better as a community as a whole. And that's the end user there.
I'll put my science hat on now. Did you come across any reports that showed that direct correlation? Because sometimes you can see things that look like they're related, but you need to prove it scientifically. So I'm just wondering if you came across reports that already show this correlation between pollution, drug use in particular, because there can be other factors that could influence respiratory health.
Well, we came up with this idea by ourselves, but as we were researching, there was a group in Taiwan who actually did exactly the same work, except they didn't link it to the amount spent on drug use, but more on hospital visits. And when they did a heat map of PM 2.5 with the hospital visits, there was a correlation where there were more visits to the hospital because of rhinitis or asthma.
I just want to add to that. So one of the major reasons, or almost the only major reasons for illnesses such as asthma is particulate matter. But there is particulate matter already in the atmosphere. It's not like human beings are the only cause of that. So the way to look at it more scientifically is to look at the change in particulate matter, that's caused by human beings. And again, we didn't have enough data to be able to do this, but yeah, these are some of the challenges for sure.
Cool, perfect. Can everyone give a big round of applause to AirCare? All right, next up is Citizen Can. Citizen Can is working on the Bring Your Own solution, but could you clarify which challenge you're working on? CSA Legacy Challenge. That's perfect. Thank you. Then on deck will be Crawl Space. So if the Crawl Space team can just be prepared. While they are getting set up, I just want to give a quick reminder. When you are presenting, we are live streaming everything. Because of the position of the camera, we ask that you, when you're speaking, be standing right in front of your computer. That'll just ensure that we make sure that you are always in frame for the video. All right, and as they get everything up on the screen, I will give you a quick joke. How do you know when the moon has enough to eat? When it's full. You say it's awful that you laughed, but no, it's awesome. It's out of this world even. All right. What do you call a tick on the moon? A lunatic. A lunatic. Someone's been here before. All right. What kind of music? This is, I feel bad. You guys are going to need to like send me your therapist bills. What kind of music do planets sing? Neptunes. No? Is that a bad one? I'm sorry. All right. We'll give him one more. What's a light year? This one's actually terrible, so I hate that I'm ending on. The same as a regular year, but with less calories. No. That was all. I'm sorry. Does anyone want to throw one in? Any jokes related to space? Only space, though. And they have to be clean because we are on Hangouts video, a live Airstream thing. I obviously work in tech. Here we go. What planet are you pulling these jokes out of? What? Oh. Wow. Things just got real. I literally think that in that moment, YouTube just changed what our rating of this video was. For those of you who didn't hear that, I'm sorry. I can't repeat it. All right. And I believe that we are good to go. So can we give a big round of applause to Citizen Can?
Good afternoon. We're Citizen Can. My name's Tanya Oleksic.
And I'm Barbara Kowalski. And we decided to tackle the CSA challenge, the first one, which talked about preserving the data, the legacy data from the Alouette 1 satellite. So this is the Alouette 1. It was launched in 1962, and Canada was actually the third country to design and build their first satellite that launched into space successfully. The satellite ended up being in space for 10 years, and the CSA had rolls and rolls of film that the satellite collected and ended up scanning it and has 1 million images of just images in their database. And the challenge is what to do with this data and how to extract data from it. And that is what we decided to tackle.
So we decided to create a citizen science project to, as a solution to the challenge and to engage Canadians and people around the world to help gather this data while learning at the same time and being able to see this, these images that were generated in 1962. So we created a citizen science project portal to Canada's space history and space future.
So the Citizen Can website is actually a framework that can contain multiple projects. The Alouette one is the first one that we're going to place on there. But essentially, you land on it, and if you are a user who's interested in space, you can actually contribute to pulling data off of it.
So if you have never participated in a citizen science project before or not really familiar with the term, just quickly, there are projects that anyone can take part in, and you can contribute to real scientific data and analysis in a variety of ways. And there's a lot of benefits that come from citizen science projects, and just a few examples are the scientific results that we receive, the data analysis, a chance to engage the public in scientific missions, creating and offering open data to the public, education, and hopefully some discovery.
So specifically about the Alouette, as I mentioned, it was launched in 1962, and these rolls of film contain data about the ionosphere. So what we did is we took these images and we loaded them onto a platform where you can see the images yourself, and through a series of questions, you can help the CSA gather data that they can't currently do.
Sorry, I'll let you watch this launch really fast before because everyone likes a good launch. There she goes. So we use the platform Zooniverse, which is a citizen science project platform that NASA, for example, uses for several of their projects to have people collect data about. And I'm going to show you our first project. It's called Agent Alouette, and this is in response to the Canadian Space Agency Challenge. So just quickly, we'll go through a few samples. So it will be made in English and French here in Canada. We'll choose English. So as you can see, it goes through a series of questions. One of the pieces of information that's a little bit of fun that this data includes, if you see a pattern that looks like a hockey stick, that represents some really important data. And so the Canadian Space Agency is looking through the images to try to capture the ones that have that shape. So we're asking you to identify, does it or doesn't it? And we're going to pretend that this looks like one just so I can show you what happens next. So let's say you say, yes, this does look like a hockey stick. There's a little tool here that's going to help you outline it and identify it. And we don't have much time left, so I'm just going to click through quickly to the next slide.
So there are lots of benefits to citizen science projects. You get the public involved and engaged. You actually save money. So Zooniverse has done studies, and they have found that through ordinary people like you, like me, doing these kinds of things, they've saved companies over $1.5 million from doing it internally.
So we actually took on the second Canadian Space Agency challenge as well, and looked at the other data set that they're interested in, because we thought it would also be a great candidate for a citizen science project. And so we created what's called RAD Views. And just super quick again, I'm going to show you a fast example. And I think we're running out of time, but just to let you know that citizen science projects are great platforms to look at a variety of data from space to Earth to animals to everything in between, and engages the public and teaches them about the information that they're helping to classify at the same time. And through our project, Citizen Can, that we hope to offer the start of a project portal to Canadian space history and its future, and to encourage CSA and other government agencies to look at citizen science platforms for data analysis and for public engagement.
Can we
Thank
give
you.
him a big round of applause? All right, judges, questions?
I'm super excited about citizen science. I have two quick questions. One, I may have just missed it. For the second project linked to RadarSat images, what will people be identifying? What's the goal there?
Yeah, sorry, with such limited time, I had hoped to go through it a bit more. But for that, there's a lot of great satellite or simulated data right now that they have, because they still have not launched the next 3 satellites that will go the next generation of them. So right now, we thought we'd set up the framework and the platform with the simulated data to have people go through it, and then it would be ready for when the real data starts coming from these newly launched satellites. So for example, we thought we'd make it fun and let people look at this data. And for example, can you see a river? Yes. And then let you sort of trace out where the river is. And then another thing we thought would be fun is to spot a coastline. And so with these type of projects, because we did in a weekend, we didn't have access to the people running these missions to find out exactly what information they are hoping to extract. These types of projects can be customized to ask the specific questions that help them get the data they're most interested in. So we just, looked for some interesting ways right now to present this to all of you, but they can be expanded upon to include further questions and challenges for the end user that will most benefit the scientists and people managing the data.
Cool. And unfortunately, we're out of time for questions. Can we give a big round of applause for Citizen Can? All right, and next up is going to be the folks from Crawl Space. On deck will be the folks from Drop the Drought. So up next, Crawl Space, and then Drop the Drought, you are up next. As it definitely kills me every time when I have to do the dance back here, I do apologize. I feel like I'm breaking every Canadian bone in my body. Not that I have any other bones in my body. Speaking of bones, why did the cow go in the spaceship? It wanted to see the moon. Moon. Hello? Tough crowd. All right, give a big round of applause for the folks at Crawl Space.
We have a problem. A very big problem. How do we create a small, isolated space for 6 astronauts on Earth while promoting cooperation, cohesion, and a healthy lifestyle? Well, introducing Crawl Space by Crawl.
Crawl Space is our design for a 6-month isolation study conducted by NASA. We will have to provide laboratory space, clinic space, as well as amenities like washrooms, kitchens, etc. However, the space is only 1,200 square feet and has to be situated within a semi-dome. How do we use such a small space to perform these many functions?
So to utilize this space, we almost created a very radial design, tried to take advantage of the fact that we're making it within one large circle. So we created a dome and then created everything within that dome using CAD software.
So as you can see that we have actually implemented quite a few things into our project, into our design for Crawl Space that allowed the astronauts to both experience, both live cohesively and with each other while being able to, as you can see, have their own personal rooms, while they can also research together. But because living in such close proximities can cause people to, can cause arguments, and that's been one of the problems with NASA's High Seas experiments. We have managed to create individual quarters for all of the astronauts that are going to be participating in the experiments by allowing everything and to be super compact. And this really increases team morale and keeps our astronauts sane during this time, which is super important.
So while looking at design, we also have to think of sustainability. So when we look at this lab will be based on Earth. So we are thinking of putting this lab on top of a mountain, which will allow us to access solar power and geothermal power, making this almost no impact lab. We'll also be using sustainable, eco-friendly materials so that this lab is as eco-friendly as possible.
The furniture will also be sustainable, made with eco-friendly products as well as being lightweight. Most of it will have multi-uses. For example, the cabinet that we designed there, it will not only serve as a cabinet, but you can attach like accessories on it to make it a seating place or to put hooks on it. And they will have hinges, so it will break down and then you can stack them and then put them away and in a small space when they're not being used. Or this dining table, it may look like a dining table, but you can fold it down to look like a double-ended couch. So a lot of the furnitures will be saving space.
So now, this comes down to the most important point of Crawl. The design is based off 2 floors, meaning that it can be separated and put in with ease, like a jigsaw puzzle. Now, this means that the entire building can be mass-produced, floor by floor, and assembled with ease, meaning that we can bring this not only to space missions for astronauts, but also to civilian use in developing countries, and also for natural disaster relief, which allows for houses, villages, and cities to be built very fast.
As our population approaches 10 billion, the available space per person will slowly decrease. That's why building layouts such as crawl space, which use very, very small amounts of space to house larger amounts of people, will be useful in the future. Thank you for listening.
All right, judges, questions?
How did you go about researching existing simulated living spaces or the existing state-of-the-art in this type of astronaut cohabitation and coming up with this design, and then, of course, applying that to what you just said at the end, which is actually quite interesting to me, which is using it for other purposes such as disaster relief or in developing economies as a form of housing?
So High Seas has an existing design currently for their interior design. So we kind of more or less based ours off that, while adding our own additional features, trying to make it more compact, trying to make it more radial. So that's how we designed ours, as well as the furniture. We did a lot of research into how to compactify everything, how to make it as multi-use and just as foldable as possible. Sorry, you asked about applications to urban environment? While for urban environment, we thought that more or less most of the buildings would end up being square-shaped as opposed to circular. You can't see circumstances where, for some reason, they have to make a very weirdly shaped building. So that's why we thought our design would be useful there as well. And the compactified furniture would be always useful for very, very dense urban populations.
For the furnitures, while I was thinking of furniture ideas, I was reminded of dormitory for universities. So I thought that was really interesting. So where a lot of people are living at once, I was thinking dormitories, this design could inspire other designs for those kind of situations.
Also, for some of our foldable structures, we based a lot of our research off some of what Professor Richard Wang from Caltech has done, in which he has based off a lot of what we use today, like airbags, for example, to be folded up in small origami structures. And we noticed how we could apply those concepts and those algorithms directly into furniture that would then be implemented into crawl space.
Did you get as far as doing any research into costing or that kind of stuff?
We were mostly focused on interior design at the moment, so we didn't actually get to the point where we managed to calculate the cost of the entire structure. But
a lot of how we made the design was to try to minimize the amount of not just the space wasted when it was fully assembled, but the space wasted when it was not assembled, when it was in progress, because each square centimeter or cubic centimeter is going to be very expensive to bring up to space. So we try to minimize the amount of like oddly shaped surfaces, curved surfaces, things that couldn't be flat, things that couldn't be stacked.
Cool. Can we give a big round of applause for Crawl Space? All right, next up is Drop the Drought. I'm going to get JK Studios to be on deck. We're going to push our break to just be right after JK Studios. After the break, the first people up will be Lark Data. So again, Drop the Drought will be up in a moment. And as we have our little astronaut get set up, we will talk about what do planets like to read? Comet books. Comet books. I do need a new shtick. I do. You're right. Can we get a big round of applause for Drop the Drought?
Hello, my name is Artash, and we have the challenge Our Planet, Our Home. And the name of our project is Drop the Drought. So our problem is that because of the climate change, some places are getting wetter, and some drier places make it even more dry. And new places are facing droughts, and droughts are lasting for longer durations. The UN has a goal by 2030 to combat droughts. Now, who is affected by the problem? Well, countries who depend on rainfall for crop and cattle, and inside those countries, people who depend on crop and cattle for a living. Now, people who are affected by the droughts are nearly 1.2 billion. Drop the drought solution. So with 15 years of data from the satellites, we are going to be able to predict when a drought is going to happen before it becomes a famine. We used satellite assessments of normalized different vegetation index.
So the solution we had was the NDVI index. It's very simple. If the plant is very healthy, it's going to absorb all the sunlight and it's going to reflect very little. When the plant is not healthy, it's going to reflect both a lot of the normal sunlight as well as with the infrared. So the issue for us is to understand how much is the reflectance of the vegetation looking at the satellite data. And as Artash said, we have 15 years of data already available for every single part of the globe. So are we able to use that data? Let's go and see.
So this is Kenya being healthy, and this is Kenya, which is below 70% of the average, which you can see is much less green than this.
The thing is, the 70% is the key, because the moment the NDVI index falls below 70%, that is a big trigger that there's something not correct in that area, and that could be a big trigger for the drought. So we are trying to assess where in the world that 70% drop is happening.
The data sets we used for the Drop the Drought. So we used Landsat 8 to get the land image, Terra Modis for the NDVI index, and Terra Aqua. We also used the population density and the human settlements. So this is the base map that we used of Kenya and Uganda. And so here is the image with the people settlements, and that with the density. And this, we want to get the vegetation, so we overlaid the base map with the vegetation. And you can see that both of the countries are fairly high in the NDVI.
Actually, you can't read the levels, but on your right hand side is Uganda, and on your left hand side is Kenya. You can see right now the red and green index. So both of them are roughly at the same index. So Uganda is 0.77 and Kenya is 0.61. So as long as the index is above 0.3, everything looks okay, which it is in October 2016.
So we got 40 different data points over 7 months to understand things better. And here's a simulation we made. So now you can see the Uganda NDVI has not changed too much, only to 0.71, while the Kenya average NDVI has gone less than 0.4, which leads to a drought. So what would people in Kenya do? They would move to Uganda, since in Uganda there's still a chance for vegetation. Yep, these are stories that should not have happened in the global news, because like we've had an eye in the sky looking at the ground for so much time, and we've still not predicted and been able to take action in advance. Yeah. And we could know what is going to happen, but no one took an action. So support the Drop the Drought application. It is natural for droughts to happen, but it's not natural if you're looking down and you're not ever taking action. For the last 15 years, we've got data. We need more space collaboration, more satellites, more education in STEM.
Yeah, so the thing was, we found the data from January that droughts going to happen in Kenya. And it was not until April when the news started coming in. So that was the biggest tragedy, where we had thousands of lives lost, which could have been avoided.
Thank you.
All right, judges, 2 minutes questions.
Hey, congratulations. That was so good. And it reminds me, I'm an advisor for this company called EarthCast, which has these satellites, Earth observation satellites, that are monitoring the Earth and doing things like crop detection and doing that type of analysis where you're looking at very subtle changes in leaf colors that can indicate bug infestation or poor water conditions. So this is a very topical topic, and I think what your approach is really interesting, because you're tackling it from a public point of view, where people can start to look at this data, apply these models and this stop motion photography, and then maybe just take action, maybe just tweet or make mention that something needs to be done because there's a border issue that may happen which leads to migration. So I don't really have a question for you. I just think that's outstanding, and I want you to keep doing this, because before long, this is going to be a real way to make positive changes in the world.
I also echo that. Congratulations, that was wonderful. And I'm curious. I'll come chat with you after. I'm curious about so many things. I know you looked at the most recent data. I don't know if you were able to get into the archival data in terms of seeing these trends over time, over the last 15 years. If you were able to say, oh, that drought happened then, it happened then, if you're seeing patterns over time. And then another thing that might be interesting from a public point of view is layering on, and I'm sure you're thinking about this already, when there's kind of a zone that's identified, like a warning. And so whether you have a key that's green, yellow, red, whatever that is, a visualization kind of cue layered on there. So it's very obvious. Great work.
Thanks.
Cool. So I think we're good to go. So everyone give a big round of applause to Drop the Drought. Next up is JK Studios. On deck will be Lark Data, but Lark Data will happen after the break. For that break, we'll take about 5 minutes just to get anyone to use the bathroom if you need to, grab a drink, and then we'll continue on and keep pushing through the rest of the presentations. Instead of telling you a joke this time, I'm going to actually tell you something logistical that needs to happen. We would like to take a group photo. We'll do this not during the break. We'll do this after all the presentations are done. The way that we're going to do that, though, some of you who are under 19 have signed media consents, or your parents have signed media consents. That being said, the over 19s actually didn't sign media consents. So during the break, we're going to have in the back by the beer area, I guess, we are going to have the consent forms that we'd ask all people who are 19 plus to sign, just so that after the presentations, we'll be able to take that group photo and the CSA will be able to share it on all the marketing materials. But that being said, let's give a big round of applause for JK Studios.
Hi, my name is Jeremy. And I'm Aduvan, and we're two high schoolers here today representing JK Studios. JK Studios. JK Studios. Dog. JK Studios. Follow us on Twitter. Okay. So, JK Studios. What are we here to present today? We're here to present our fabulous new invention, edidle, where you can come and fly with your food. Bro. Where you can come and fly with your food. Okay, so jokes aside, let's get to actually what we're doing here. The mission we chose to pursue was Pilots Plus, the NASA Space App Challenge. So what this mission statement is, it's basically telling us to build a tool that allows pilots and passengers to identify geographic, natural, and cultural locations of interest along their flight path. Obviously, this is a very broad statement with a lot of nuances, so we had to spend some time to figure out exactly what we're going to focus on. I want you all to know that we restarted 3 times and focused on 3 different things. So the first time we decided to focus on was allowing pilots and passengers to identify geographic, natural, and cultural locations of interest. Then we gave up and decided to focus on geographical, natural, and cultural locations of interest. Now we're just focusing on the interest part. So we decided what is interesting. And let's be honest, what is more interesting than food? Among all the jokes that James said today, food got the most applause out of anything. So I guess that tells you all how much interest you are in food. But I mean, it's not to be blamed. Let's look at all the kinds of food we have. Food is a very global market. Everyone loves food. There's lots of different types of food. And that's why we feel food can come and connect the global community to make the human race a better place. Obviously, I can philosophize days, but let me focus down, let me narrow on the specifics. If you think about it, when you're in a plane, there are not many things for you to do. You can sleep, you can eat, and you can go on your phone. So we took the going on your phone part and put it together with the eating part, and we have edidle. So what is edidle? edidle is an app for Android. It is developed with Android Studio, and it was made in about 5 hours. So basically what it is it's an idle game. If you guys have played Cookie Clicker or Venture Capitalist or something like that, it's not a large-scale project. It is definitely something small-scale because it's something we could put together and we could actually visualize. So what edidle is doing is basically you start off as a regular citizen. You are one person by yourself. And as one person by yourself, you have access to only one food item. Jeremy, start the app, and we will show you exactly how it begins. Right there, yeah. edidle. That's McDonald's, Jeremy. That's the wrong app. Jeremy, go open edidle. We do not associate McDonald's in any way, shape, or form. I'd like you all to know that. I'm actually a fan of Burger King myself. Okay, so I've been told to keep talking and stalling. So this is a Nexus 5 app right here. Okay, I'll keep going anyway. Basically what a idle is you start at your origin airport, right? So let's say we're taking a flight from Canada to New Delhi, right? So we start in your origin airport in Canada. Then your home food will be the poutine, because that's what Wikipedia said Canada's national dish is. So we took the poutine. As you can see, there we go, starting with poutine. Now what's happening is, because it's an idle game, there are two key mechanics. There's idle implementation, where you automatically increase your funds, and there's manual fund increase. So Jeremy, if you could harvest the poutine, we got $100 right there. So what's showing heights here is you have one citizen. You're by yourself, you can only make so much money. But as you fly over other countries, you'll get other people to join you. We're using a GPS spoof or something right now, so basically in 45 seconds we should be passing over France, and once that happens, we'll add another citizen to our tally, and we'll get the food of a crepe or whatever. And basically what this is showing is, as you're flying along your route, you can come and associate with people from all over the world, you can learn about all their cultures, at the same time you can find something relaxing and entertaining to do. France is going to show up soon, but while waiting for France to show up, there we go. See, France showed up, your location has changed, you're in France right now, there's 2 people helping you out, now you can harvest crepes. We have 1 minute left, okay, so we're going to rush through it. See, Jimmy, if you click the info button right there, I want to show this not just for entertainment purposes. We also have information on board. So regardless of what countries you've unlocked, if you're feeling interested and the app is really enticing you, you can in fact go and look at the country yourself. So let's open France right now. And you can actually get information about the crepe. And you can go and make the crepe if you go home and feel like feeling, crepey. So basically, you can connect yourself more to everyone around the world. You can learn more about cultures while at the same time you're not getting bored. It's not like class. You're not reading and reading. You're learning, and you're learning through entertainment. Jeremy, go back to the store page real quick. Back into the store page. Obviously, it's also a game. You can increase your solo levels. You can increase your citizen speed. You can purchase things faster. But regardless of how efficient you make things, regardless of how fast you can do things, you can't actually increase your output dramatically until you get more citizens. Because getting more citizens multiplies your output, and that can only be done by flying over more countries. And that can only be done by taking the time to visit the world and make the world a better place. By connecting yourself to the world, we are showing you that you can indeed make a difference, and that together we are stronger than ever. And that is Ed Idle. Thank you very much.
I'd like to make a note that I think I just got completely shown up in all the jokes. I don't know why you guys are pooping on me. Note that I said pooping, Uranus. All right, judges. Judges, 2 minutes for questions. No questions. Ladies and gentlemen, let's give them a round of applause.
Yeah.
All right, so what we're going to do now, before I say go, don't do anything, we are going to take a break for 5 minutes to grab a drink if you need to go to the bathroom. More importantly, again, if you are over 19, please go to the back by the beer fridge. You will sign a media consent as long as you're consenting to have your photo taken by the CSA and used by the CSA in some marketing. Otherwise, hang out. And when we get back in 5 minutes, Lark data will be up, and then on deck will be Pinball Blizzard. All right, thank you.
I don't know what happened. Thanks, man.
Say your heart, say your mind, say all you hide. I won't let you
So again, check, check, mic check. Can you hear me now?
What if I go stronger? What if I get higher? What if I start doing things I know I will regret? I will make my own way, I will not surrender. I will do my best until I get put under. What if I go stronger?
Check, 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 check. All right, ladies and gentlemen, if you could start making your way back to your seats, that would be fantastic.
Okay, talking people. Yeah. Okay.
we could also get the judges to their booths, that would be fantastic. The judges to their booths. We're just giving the judges a couple of seconds while we do. There's a charge spot little USB dongle that is missing from one of the boardrooms on that side over there. If you have it, it's not useful other than the table. We're just wondering if you could check your phone, check your bag or anything else, make sure we do not lose this charge spot. If you have it, if you could return it to me, that would be fantastic. Just wait for the last few people to come up, and then we will get started. Since the music went down, I am going to now tell you jokes.
Gave you too much, now I'm swallowed.
Why don't aliens eat clowns?
Now I'm the fool while you're breaking rules. Dangerous path that I follow. Oh, go on, just do what you do.
What do you have about favorite piano keyboard?
As I bleed for you, cry for you. Let me
Not at all. Not making me go down on myself.
as I bleed for you, cry for you.
Alright, thank you. Thank you. I'll be here for the next few hours. Good laugh, thank you. And as our judges make their way to their seats, we will get started with the team Lark Data. Give them a round of applause.
Hello. Hello.
Yellow.
Oh. It's just really quiet. On the chin.
Hello, everybody. We will be presenting a solution for the first problem set provided by the CAA. Our product name is, CSA. Our product name is called Lark Data, and this is what it is. So back in 1962, Canada's first ever satellite launched, the Alouette #1, has been collecting valuable data on our ionosphere, and it's sent to us in the form of 35mm film ionogram images. The problem is that this valuable data contained in millions and millions of images gathered for over a decade is extremely challenging to decipher, and it's difficult to sort and manage, and it's difficult for scientists to use. So, but now the ionograms have finally been digitalized, and our solution for this problem is to build a tool to collect the metadata. Next slide. So we'll be looking at the images, trying to organize it in a way that is searchable and meaningful for the data users and scientists. Some ways that we can use the data in the future is to understand how the ionosphere can affect radio propagation signals. So for example, radio waves, Wi-Fi signal, and cellular signal. And we want to figure out if we can see trends, like if the properties of the ionosphere depend on geographical location, season, or time of day. Next. So now I'll bring it over to Jim, and he'll talk about the back end.
Okay. Basically, we were trying to capture data from a really difficult data form. As you said, it was 63, so there was no such thing as digital, fundamentally. So what we have is dots on a film, where the position of the dot says what the value and meaning of the data is. The trick being, of course, is that this position is not consistent either from frame to frame or, in fact, within the frame. They have rows, and they have rows and columns, and it's supposed to be a rigid array, but the individual dots drift. So what we did was we downloaded a subsample of the data. The other thing is the data is huge, because the data is captured at 35 millimeter resolution, so it's like 40 megs per frame. So what we did was we built a tool that scanned through, identified the dots, worked out the position, and then we experimented with a filter that would actually identify the dot with a reasonable reliability to turn that data into a database, which we can then use to drive a website, so people could say, I want to look at this picture, find it by date or by a couple of other things. It's mostly timestamp, and that was the fundamentally it. I think we skipped one. Okay, yeah. So this is what we did. You know, we scanned it. We did find a trick. There was one dot that was always in the same place. So we used that as an anchor to figure out where everything else was, and then we doing the scan, and then worked out the data. So that was the algorithm that to really do this properly, you need to have the whole data set, and the only way to do that would be to work inside the data center, because the whole data set is just too big to move around. All right. Next.
Now for the front end of it. When working with this data, one thing we realized was accessing it really sucked. Like said, each image was actually about 40 megabytes, and there's like 1,000 of them, so that's 120 gigabytes. And that's only a small portion of the 1 million that they have. So our solution is to create a website which is easily accessible by all devices like mobile and laptops and computers, and have it organized and presented in a really professional and clean manner. So we have two teams working at the front end. We have people interacting with the database using PHP, meaning we have our site and using code, we are able to extract data from the database and put it onto the website, as well as designers to produce wireframes and front-end developers to make it happen. So our website consists of 3 sites. We have our landing page, which we would like to call our very general picture, which is where you can narrow down your search. Next, we have the results page that has all the results from that search. And from there on, get even more specific, where we have a single individual page that shows the graph and the specifications obtained from our algorithm. So we would do now we would do a demo of our site. So here we are, log data. If we had a domain, it will be logdata.space. And
sure. So very quickly, you would just enter the date and time, and this would be in UTC format in terms of time zone. And you just press submit form, and it would bring up all the images, and you can view the image, and you can also download, and it's a straight download link to the FTP directory. If you click view image or view, it would bring up the individual image, and then also the station number that's associated with the image, and also and you can go back and refine it based on station, and also specific days within that as well. And this is just a small sample set of the huge amount of data that's available.
So to wrap up, the people who we would have questions.
All right, judges, 2 minutes for questions.
Oh yeah, this is our team of 12 strong.
Okay, so it's a huge team, and I mean, I saw your product. I get it was a challenge for this CSA data for the Alouette. But does anyone in this group of 12 of you, can you think of what you would do with this going forward? Like after this is over, like is there something here that's truly interesting to the world, or to consumers, or to researchers, or to space agencies to keep you guys, in business?
So the graphs that we were given, like the dots that you saw in the upper portion of the graph, they're not actually readable by normal civilians. You would actually have to get an ionosphere specialist in order to look at these graphs and sort of decipher trends, or to look at the data and see any sort of relevant information. But the ionosphere is only affected by solar radiation. So any changes in solar activity will affect the ionosphere, and this sphere, as I mentioned before, does affect radio propagation. So, like, I'm sure everyone uses Wi-Fi, everyone uses a cell phone, everyone uses radio waves in some way or form. This ionosphere will change how the waves bounce off of the layer, and it will affect how the signal is broadcasted from user to user. So this is how it affects the world.
In the challenge, the CSA specified that the major application would be them, that there was something that they really wanted to do, so that they could actually find the data that they actually had, rather than have it piled up and basically inaccessible. They did have a few other suggestions to make it that other people could use. One of the more interesting ones was they suggested that somebody could actually take the pictures, and because those are actually frequencies, people could actually turn them into sounds. So there's a conceivable, like, it's raw seething data. It can be used for anything. It's now basically available and findable. So we do not have a target market, but other people may find interesting things to do with it.
Cool. Can we give them a big round of applause? Next up is going to be Pinball Blizzard, followed by ASAN. We're going to fit them in on deck. So again, Pinball Blizzard, and then we will go back to get ASAN afterwards. I'm not going to say jokes this time because I really didn't feel welcome last time. But for those of you who did miss out on the consent form because we didn't have enough copies out, we are getting more copies. When we do have those copies after the presentations, we will give everyone the opportunity to do that before we take the photo. And I don't have my phone with me, so you're lucky. I don't have any jokes. Thank you for that round of applause. I really love being here in Toronto. Here we go. Folks, give a big round of applause for the folks at Pinball Blizzard.
Thank you so much, everybody. So we are Pinball Blizzard, and we want all of your help to turn the clock back on climate change. So there's lots of data and information that shows our impact on current ice conditions in the poles, specifically the Arctic. And we want to be able to harness that historical and current data in a meaningful way, data about our own planet, to be able to have just an impact on how people are viewing our world. And we wanted to create a fun and accessible way to interact with that NASA ice cap visualization data to increase both awareness and the capacity for climate change impact reduction. So overall goals of this specific challenge was to have a data visualization tool to be able to show the changes in Arctic ice to a general audience and to sort of tell the story about it, because really this data is a story and it's really important and necessary to be able to interact with it to understand the impact that we've had as a species on our planet. And the overall goal of the education and awareness raising are just our awareness of our capacity to be able to have an impact is important to us. And also, so the ability to see data is really important, but also to be able to play with it is another way that we think will create a meaningful experience for people. So we built a fully functioning digital game that's projected onto a physical pinball board. So you may have seen us carting it around, and I hope that you'll have a chance to come by and play it, but it actually works. So I'll take you a bit through the process, if it will switch slides. Okay, so here's a little bit of the process. So we actually use digital fabrication and CNC machine to create the physical pinball board, and it also spins. So the board itself, the pinball, you can actually launch the balls, and the hole itself is actually spinning. It's kind of intense. And there's also micro switches that hadn't been installed in this video on each part of each of those small wooden blocks that trigger events in the actual game. So the projection itself looks like this. And I'll talk you through a little bit about the gameplay as well. But this is based on sea ice thickness data. And we're projecting that information onto the game board, and you're able to interact with it by hitting those micro switches. So there's going to be a little bit more of an extended demo, and I'll talk you through the gameplay as well. But the scoreboard status is actually the Arctic ice cap. It won't change slides. There you go. So the scoreboard status is actually the Arctic ice cap itself, which is the visualization of the NASA data set. And there's 2 pinball shooters and multiple time targets that appear. And those are either positive and negative impacts that we're able to have on the ice cap data itself. And you have to work together as a team to reduce those human effects on the ice cap and promote positive change. And it gives a chance for a learning opportunity to interact with that data, and also lets us consider the impacts of our actions as well. So this is an open source product that we've created, and the plans for the construction and the game itself are all available. Anyone can build this game themselves at schools, science centers, museums. NASA Space Center Houston would be a great spot to put it. And we can also be commissioned to build the game for you as well, because we want to make it accessible for people to actually be able to play it and interact. And the game is also a self-contained digital entity, so it can be released for iPads. With the Ontario Science Centre, and we want to be able to exhibit this game as a starting point, but we really want to be able to delve deeper into the opportunities it could provide, and continue on with the project, and be able to, again, open source those files and plans to raise awareness of this project, that it exists, and be able to build it out as a standalone app, and also add more data and increase the algorithm complexity to the actual mechanics and interaction of the game. We were able to accomplish a basic interaction over the weekend, but it has a long way that it could go with more time. So we also have time for a quick demo in the back if you want to take a look at it in real life. So the camera is going to go over to Andy. Yeah, so you can keep looking at the front. You don't have to physically get up and walk over. That would be crazy. But you need the mic.
All right, follow me digitally, and then you can follow me physically later and play the game too. So here we have the game. So you can see there's a kind of vortex in the middle to make it more challenging, and we've got these pinball shooters on the side, and micro switches ring the edge so that you can hit these different targets. And these targets represent things that you can activate. So there's replacing coal power plants with solar plants. There's a different kind of research things that we can do. If we can research electric cars more and research electric cargo ships, there's big differences that we can make on climate change and thus on the ice caps through these actions. So you can see there's some text that appears around the side teaching you about the things that you're doing at breakneck speed to learn as you're doing it. And that visualization in the center there is from data from NASA that has the actual climate data from 1984 through 2016. And you can see over time as the ice cap shrinks and gets smaller and smaller, and you just saw the end of the game there. If you get all the way to 2016, then you've lost the game. You didn't prevent the ice cap shrinking enough. And as you hit those other targets around the edge, you set that clock back. The clock's displayed on the shooters there, you can see. So that the idea is that you keep setting the clock back from what we've already done as a species and make the ice caps larger. So thanks very much for watching, and I hope you can come and play with it later.
Give them a round of applause, ladies and gentlemen. And the judges, you have 2 minutes for questions.
That was awesome. I actually came into this cold, so when you were talking, I was thinking, oh, this would be great at the Ontario Science Centre and at TIFF, like TIFF Kids, and so that's awesome. And so did you like woodcut, like laser cut all that this weekend?
Yeah, so we split into 2 teams, a digital team and a physical team, and the physical team built that whole thing just this weekend from Friday night onward. We had like a minimum viable product that was smaller in case they didn't get the whole contoured, sculpted shape on the CNC machine, but they did all of the steps, which was pretty awesome.
Yeah, well done.
Yeah, do you want to know anything more about that?
So for the fabrication of the piece, it ended up being about 6 hours of milling on our CNC router, which is essentially just a machine that can cut using what's basically a drill bit and can cut contours. So it was 6 hours of milling for the center, 6 hours roughly for the outside as well over the past 2 days. And then a lot of wood glue.
And it's also a digital file, so this is scalable because now that this initial digital prep work has been done for the creation of the game, the physical part is also really scalable. So we could send the files we created, which you can see up here, we could send those to science centers and institutions all over the place, and they could be able to access a local CNC mill and just sit there and watch it happen and be able to assemble it based on the plans we've given.
Cool. Can we give a big round of applause for them and their fantastic challenge solution? Challenge solution, that's what I'm saying. All right, next is going to be ASAN, which is doing the Data Concierge Challenge for NASA. So just give our judges a couple extra seconds to get set up for that one. On deck will be Sustain City. I actually don't have anything to say this time. This is... Yes! Never gets old. Never gets old. Yeah, poor me. I go home and I cry. No, that's not a thing. Don't. I got an awe. I feel better now. I'm not entirely sure why they give me a microphone. Every year I tell them, don't do it. It's like you all are masochists. That's what it is. All right. Give a big round of applause for the folks at ASAN.
Okay, good afternoon. Our group is ASAN ***. My name's John. This is Judy, Ronnie, and Akash. And we struggled a bit at the start because we thought we were going to do different things. And Saturday night was coming around and time clock was running down. So we decided, especially Akash, who slept over all night. She was the only member to do so. He should get an extra round of applause at the end. And so it was really commendable. And we came up with this name. Does anyone know what ASAN stands for? No idea? Okay. I did. I was walking home Saturday night, and this little piece of rock hit me in the head, and the paramedics came, and they said it was a meteorite piece. And I recovered, and I looked up, and I saw these stars, and lo and behold, there was a space station flying over. And I remembered that because on Friday night, the opening night, the astronaut said, "You can see it. It's the third brightest light." So without further ado, I'm going to hand it over to my compatriots.
So our challenge was to build a data concierge, which is basically for someone who needs NASA's data, such as the moisture level in the air or the nitrogen levels in the air, such as farmers when they're farming, agriculture. So we wanted to build a program that would make it easier for users to access this kind of data. So here's our program.
So basically what we did was run like a chatbot in Python. So which will, like, you can give like a search data or whatever your requirement is, and it will go to NASA's database and give you that data, and you can browse their database. We also wanted to add like deep learning, so it can like, based on the searches or your requirement, it can be trained so what data the user requires. So it can automatically come up with suggestions that it thinks that would be useful to you. Say like a farmer says, I'm a farmer, so it can say what data would the farmer require to like maybe harvest crops or whatever. So I'll just run the code now.
Hey, I'll be talking over the live demo. So, just how are you doing? Our program name is Dr. Cooper. Sounds smart. Good. Awesome. What can I do for you? I am a farmer. I could provide you data from water, groundwater, and soil moisture. Are you interested? Yes. Do you want data on agriculture or farming data sources or recommended data sets? Agriculture. Data incoming. And then we asked, what did you search?
So it took you to NASA's data website where it shows you all the data relevant to agriculture. What did you search? Tropical. Thank you for your input. So now.
So basically, when you give like, what do you search? So it says tropical. So it's saved in a CSV file. So the program can learn that what is your, like what input you did. So next time, instead of just going to the page of the data search, it would directly go to a search query, and then you can just extrapolate those data rather than typing it.
So another example, he's searching for landslides. So would you prefer raw data or data sets on map? So he searched map, and it shows him a map of the landslides from NASA's website. So you can search anywhere you are, what landslides are better, where are they where are they exactly, causes of the landslides. Yeah, so it just makes it a lot easier for users to access this data. Instead of searching for it, they could just type in what type of data they would want, and it comes up. So meteor. I have report for meteor landings in Earth. Don't lie, I know you're interested. And it shows you all the meteorite landings on Earth from NASA's data website. And this is our program.
Thank you. Judges.
That looks great. Thank you for sharing that. One of the questions I have is, it looks like one of the minimum system requirements for using it is that you need to know English. Have you thought through actually internationalizing the input so that it actually becomes a globally accessible tool?
Yes, I've been thinking about it. And one more thing I was considering was that because this is a deep learning thing, so as you keep giving inputs, it starts learning. So if it starts using like geo coordinates and stuff, so it can automatically understand where you are and then start probably talk in the language which is generally spoken in that location. So I would say that for that.
Yeah, thank you for the presentation. So now that you actually have or are giving access to, now I can, as a user, I can now access this information. You guys have allowed people like me to actually get it like a lot easier. What does the next step look like? So where do you go from here besides the accessibility?
So what I was thinking was using like image learning. So this can get all the data. Like probably like one of the projects was the drought project, which I really like. So if it gets that all the images for the drought thing, so you need not actually give you like a data saying, okay, measure this. Since it already has image learning, it can just tell you this is the day you'll have probably drought or something. So you can process from that. So that's my understanding for that.
Also, what we could do to improve this is instead of going to a specific URL, we can take all that data and put it in a specific spreadsheet and access that spreadsheet instead of going to NASA's website. But we wanted to do that, but we knew that it would take a very long time to get and extract all that data.
We actually have like a few spreadsheets, but I just didn't show because it's like the repetition of the same thing. So.
All right. Give them a round of applause.
Thank you for
ladies
listening.
and gentlemen. Next up, we have Sustain City. And on deck, we have Well Loved. While they are getting set up, I do have some logistics to let you know about. At the end of all the presentations, there are a few things that are going to happen. First, we are going to drop a link onto a slide for everyone while you're on break and waiting for the judges to deliberate to a type form that you will be able to fill out to vote for your People's Choice winner. Again, reminder that you vote once, and we ask that you don't vote for your own team. And that'll just allow us to make sure that we can send the best folks up as well, not just the largest teams. As well, for those of you who are wondering what happens if you win one of the NASA or CSA challenges, we will tell you after Sustain City presents. That was like amazing. That made me sound like I was a super cliffhanger now. Everyone give a huge round of applause to Team Sustain City.
Hey guys. So we are Sustain City, and we are a bunch of strangers that came together on a Friday night, and ranging from data analysts to consultants to a lot of insanely smart high schoolers. So I can't wait to present you this solution to you guys. So my name is Garlam, and I love parks. Now, humor me for a second and step into this park with me. So it's beginning of June, the weather's beautiful, there's people there, people are playing frisbee, dogs are running around, people are doing barbecue, and you're just taking a stroll throughout the park, and it's nice. Now, you're taking a stroll, and you come to this area where there's wrappers, there's all these different bottles, and then your perfect day is just ruined, you're upset. Now, I could do this and go complain on Facebook, but I don't want to be that guy constantly complaining about how dirty the city is, right? And in a connected world like this, it doesn't make sense that we don't have a platform where we can empower people to clean up after ourselves. So we start with a statement that how might we empower communities to sustain our local environment? How do we empower people to sustain after our own city? And do it in a way where it's so easy that we can do it like that tomorrow. So our 3-step process gets you from a very unengaged bystander to a passionate citizen. And it all starts with this poster. So I'm walking around, I see a wrapper, I'm upset. Now, I see one of these posters hanging by a tree or a lamppost, and I'm just like, all right, there's 3 faces. After seeing this wrapper, I'm definitely either sad or angry even. And it says at the bottom, talk to our bot to help understand typing this really simple URL in your browser. And I'm gonna pass it off to our genius coder, Derek, for demonstration.
Hi. So this is a Facebook bot that I built for this project. So when you click on the link or type the link on your smartphone, it will open Facebook Messenger and you will be greeted by this message. And then it will ask you to type feedback. We can ease that process with a get started button that we type for you. It asks for your location. You can send your location, your current location or your closest location. We can check with Foursquare API to see if you're in a park. Here you see the option how you feel about that park. And then we ask you to send us a picture. And it works with the camera of your smartphone. You just press the send button. We receive the picture. And that's it. And all of this can be easily integrated in a database with your location, latitude, longitude, as well as the picture. And because the picture is hosted on Facebook, well, we don't need to have storage for the picture. We just save the URL. That's it.
So after the bot redirects the user to our website, which is going to be launched using a .space domain. The landing page is going to show this, a complete map of Toronto and all different parks are located within. So the user can go and either search their city or they can go and simply use their mouse to hover over one of these. And it will show a bar using our data that we've collected. It's going to show whether the user is, sorry, just some technical difficulties. Wait, it's not going to show up?
Yeah, it's not showing.
It's not showing up?
There we go.
There we go? Oh, okay. Just retrace. It's okay. Okay. Where's the mouse? Okay, so sorry, using the mouse, you can go here and hover over. And you can see there's a bar of people who are feeling happy with the park, sad over the park, or they're extremely angry. And this is using a data that we collected from people who have submitted data using our bots. And when we click on it, it redirects us to this, where we can see exactly, here it says 65% of park goers are sad about this day. And it shows us all the images that people have sent. Which really highlights exactly how they feel about this park and how sad they are about it, how angry they are about it. And because this is we feel like this was such a bit of a negative message, perhaps it might drive people to perhaps not want to come to the park. Therefore, we also added a component over here where it shows a more positive side to it, which we include images of people who are participating in volunteer activities and things like that, so we can entice people to visit the parks. And we've added something on the side. Because this is very much crowdsourcing and we want people to participate and really make a tangible impact in our parks, we have things like donating $5, perhaps volunteering with a friend, maybe sharing on social media. So it's very collaborative. It gets everyone involved and makes everyone feel like they have a positive impact.
Perfect. Can we give them a big
Thanks, guys.
round of applause? Judges, 2 minutes for questions.
That was great. I just have a quick question about maybe resolution of data, for lack of a better word. So comparing High Park to, say, a parklet, which is very small, can the map kind of zoom into, say, problem areas within High Park, so it's not necessarily a reflection of a huge park? Like maybe you can see where the zones are that need help?
I think it's a really good idea. It's something that we can try to implement in some of the future models that we have.
And currently, this is sort of static. We can't zoom in yet, but that's a very good idea. I think it's something that we can definitely research.
Did you consider how sentiment changes over time? I didn't get an impression of like, is there a way to resolve complaints and things like that?
Yeah, so that's what this whole bar is about. We didn't want to make it, first we had an idea of having just one face on there, but we wanted to make it some kind of a tug of war where you're actually seeing how you're influencing the sentiment people that have towards the park. So if you go to our next screen here, just a screen here, we have all these. At the top, we have a positive bar and the negative bar, right? And as you're helping out, submitting photos on your volunteer activities and taking these challenges, spreading media, social media, you'll realize like how that bar is moving towards more of the positive side. And that's how we're trying to get people to change their behaviors and look after their communities. So yeah.
Cool. Again, another big round of applause for Sustain City. Next up is Well Loved, followed by Yams. So for those of you who caught that cliffhanger before Sustain City, for those who win, you're probably wondering, you know, what happens after you have the local judging and you find out you either the NASA or CSA delegate going up both internationally and nationally, respectively. What will happen is you will be asked to fill out even more that profile that you put on NASA's website on spaceappschallenge.org to fill it out with more information on your idea, how you built it, why you built it, what sort of problem it solves, as well as provide a 30-second video that explains and shows what you did. You will have a little bit of a tight timeline to do that. It will need to be done by Friday so that judges can deliberate. And they expect to take about a month to figure out the international winners on the NASA global stage. That being said, we are also here as an organizing team to support those who would like to take it further. Sunil will talk about a really good opportunity for those of you who might be interested in taking your ideas further as well a little bit later. For the people who do end up getting those challenge or going on for national and global awards, we will kind of keep you back at the end just to remind you of some of those details. So don't worry if you don't remember them. Yeah. For those of you who didn't know, there are actually 200 events happening this weekend for Space Apps in the largest Space Apps challenge ever. This being its 6th year, they're expecting the most participants ever. Last year we had 165 cities, I believe. So definitely growing year after year. And other useless facts, did you know that a pickle is actually a cucumber, but pickled? I didn't know that until honestly, a couple months ago. Ladies and gentlemen, our education system is fantastic in Canada, especially for those of you turning in around the world. And I will now throw it to Team Well Loved. Ladies and gentlemen, give them a round of applause.
Okay, so hi, my name is Janet. Here we have Matt, Bliss, Dima, and Ahan, and we are Well Loved. So every day, 26% of the fresh water withdrawn in the United States comes from groundwater. 36% of that fresh water withdrawals are used for irrigation. The numbers vary by region and country, but with approximately a quarter of our water coming from groundwater, the importance of monitoring it and maintaining their levels can't be understated. Not only do they contribute significantly to the world's supply of drinking water, but they act as a primary buffer against droughts by offering a more stable supply of water sources when others become depleted. So by monitoring soil moisture and predicting weather, we can help stakeholders, including farmers, gardeners, urban planners, etc., mitigate the amount of water that they need for irrigation by giving them real-time data on their soil conditions.
Our stakeholders and partners. Our stakeholders also include, we have a large variety of stakeholders. They include farmers, landowners, and managers who need to use this data to understand their soil conditions better, and governments and corporations who would use this information to look at their municipality or their company's water usage, and as well as research organizations such as universities and even NASA. We plan to build partnerships with some of our larger stakeholders and corporate influencers while engaging more specific end users on the appropriate channels.
At this point, researchers have created a very accurate database of groundwater storage by using satellites. And although the information is readily available, it's very cumbersome to navigate. And so it's only accessible to a small subset of stakeholders who have the ability to interpret it. So our objective was to create a program that will help each and every one of those stakeholders easily access the information that they need to achieve their goals. This challenge addresses 2 sustainable development goals adopted by the United Nations General Assembly, who aim to build a better future for all people by achieving sustainable development in 3 dimensions: economic, social, and environmental, all in the spirit of a strengthened global solidarity. So the first goal is that by 2030, they want to implement integrated water resources management at all levels, and the second goal by 2020 to protect and restore water-related ecosystems.
So for our project, we had a nice little brainstorming session, and we figured out that we wanted to make the information accessible to everyone. So we're going to go through the internet with a web-based app, and we were going to include things like the user's location, try to figure out the groundwater at that person's location, the soil moisture content. We were going to include like an Alexa voice command that you could ask, am I going to be drowning in the next 24 hours due to flooding, or something crazy like that. A lot of these features we ended up having to push out into our future kind of updates and things that we had to do like that, but we didn't have enough time because we found out a lot of issues, as you all know, accessing the NASA data isn't very easy. But eventually we managed to get a hold of some satellite live data. So the data that we have in our app right now, and it's posted on the net right now, you can visit it, is from Thursday. That's the soil moisture content in all of Ontario. And we also have included the weather. And we're just about to release the water table data as well, which we had difficult finding. So we've included satellite data. And I guess Melissa is going to show you kind of the web interface.
So Matt was able to pull down the satellite data and process it using R, and we were able to implement it into our web app. So this is running now, so what this web app does is I have no idea where the mouse is. To the right? To the left? I don't know. To the right of the screen? Oh, all right. That's fine. If you guys want to check it out, it is online right now. You can see it at well-loved.github.io. Basically what it does is when the user loads the page, it'll load their location, and it'll automatically look for the nearest point and give you the soil moisture content as well as the forecast, so that they can figure out whether they need to use irrigation to actually water the crops.
You can quickly see here, you can choose a point, find out the weather, find out soil moisture, find out whatever you need to know. We've kind of built it with in mind that there's going to be a lot of simpleton people using it, so we just wanted to extract core features of the data set from NASA and plug it in. Yeah, I was just refreshing. How do we go to the next?
Yeah, unfortunately, you're out of time. Okay. We can get the video running in the background while the judges are asking questions, if that works. But as we do that, judges, do you have some questions for the team? Yeah, if you'd like, you can press the. It's not the video's not. Okay, cool. So, judges, any questions?
I don't have a question. I just want to say great job. And I was curious. I know you already mentioned some next steps around voice recognition. Is there anything else that you want to comment on?
Yeah. So the whole idea is that look, NASA's data not very user friendly. So essentially, what we want to do is bring it down to a simple level, so a farmer, a land register, whoever can understand and use this data. And also next steps is taking all this existing data and start forecasting. So taking weather data, water data and stuff, and just putting it up in front of the user so they can actually start making better informed decisions, especially if you're a farmer, all the way up to a municipal worker.
So yeah, ideally our next steps would be to kind of get the government support behind it, because if water conservation is in the government's best interest, so hopefully they would be paying us to get the data that's already out there, give it access to all these consumers, all these farmers who might want to know what that moisture content was, and also the mineral makeup is also available in the satellite data. There's just such a wealth that bring it into something that's easy. You just click, 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 you can move around, you can see exactly where you are, kind of where we want to go.
I will just say that, and this actually applies to a lot of the teams here, is that we're looking at geospatial data, satellite data, space data, solving these problems. But in almost every presentation I've seen, there's also this massive data repository out there that we just generally called open data. And so these are data sets that municipalities have released, provincial governments, federal governments, global organizations. And it's that synthesis of data sets from space, geospatial, with open data sets that can create some type of a usable product that resonates with some type of customer. So here, obviously, cities or governments or potentially users, citizens, property taxpayers would be interested in types of water data. Water is a massive industry, a huge industry, and you're disrupting it. And I think the comment is just across the board to a lot of the presentations I've seen is I want to see what's next. Like what did we just do a project here on the weekend, or we actually have a plan here to launch a company, launch some sort of disruptive technology? And for that, we really have to use open data. I've made an investment in a Toronto-based company that's called Think Data. ThinkDataWorks.com is the website, and they've been using parks data, city data, neighborhood data, open, basically citizen contributed or government contributed data sets, and that they're available to you to use. And so I would recommend a lot of people look at those type of data sets as you keep going forward.
Cool. Can we give a big round of applause for Well Loved? Next up is Yams. And after that will be Yes, I Can. And Yes, I Can will be last but certainly not least. So again, after the presentations, just a reminder that we will put up a little link for the forum for People's Choice that everyone will be able to vote on. As well, our lovely food will likely arrive, or hopefully arrive, while we wait, so that we will be able to indulge while waiting for the judges to deliberate. And here we go. We have the You Are My Sunshine Yams team. Give them a round of applause, folks.
So hello everyone, we are the YAMS team, and this is our solution to the 2017 NASA Space Apps Challenge. So the problem we had was that we needed to measure solar energy output over time and explain to users who don't really know how solar energy is generated, how that really works. The secondary objective for this challenge was to optimize energy consumption for the HI-SEAS project. So what most people don't really know about solar energy is that it's not actually a constant feed. So it's very variable over time. The two things that influence it are solar radiation and panel output, which we'll cover now. So solar radiation, or insolation, is influenced by the time of day. So there's no solar radiation at night and lots during the day. The time of year, so lots during the summer, not so much in winter. Your location, which is influenced by your latitude. And the weather adds a random component to insolation. And then we have our panel output factors, which are the type of solar panel, area covered, and panel orientation. So this should give you an idea of the kinds of variations you'll see across the planet when it comes to solar insolation. So the blue line across the top is around the equator. So around the equator, the amount of insolation doesn't actually change that much throughout the year. But if you look at the yellow line, which is near the poles, it actually changes dramatically. So if we were to use an average of solar insolation over the year for this, you would almost never be on point. It would always be off because it's either going to be at a high or a low. And an average point is not actually accurate. So next we'll take a look at the website.
So this is the website that we created, and users can use this on their phone and on their desktops. And the main purpose of this website is to let them know about the benefits and of solar energy and what is solar energy and how does it work. It gives them a good understanding of what they will be using, and more people should be using these renewable energy sources, and we cover many of the benefits of switching to solar power while educating them about how it works. So here we explain the types of solar panels that they could be using, companies that provide these solar panels, and as well in this particular section, we explain we give them a good understanding of how much money they should be using and spending when they are planning to buy on a solar panel. So we give them a graph and a chart as well, and we also provide them an energy consumption calculator to help them to let them know how much money they could be using in the future or how much money they are using now.
All right, so next we have the target audience of this website. So we'd be looking at homeowners, as well as businesses and the space industry. So this could be used for any kind of applications ranging from appliances, household appliances, to manufacturing equipment at various businesses, or even the instruments on satellites. So just a quick little demo here. The top line is the average household consumption of energy over a 24-hour period. And the line on the bottom is the energy output of an installed array of solar panels equaling 4 meters squared. So if we were to double this to 8 meters squared without changing any behavior, you see that the actual time period that you're collecting the solar energy does not actually change. So the peak moves up, but all that extra power has to be either sold back to the grid or stored. So if you were able to change your behavior instead and change the top line, you could actually use more of your power within that period and save more money. So this solution would have a big impact in several ways. First of all, it would be a cost-effective solution for people who are looking for energy consulting. Obviously, if you wanted a really comprehensive analysis, you'd be paying thousands of dollars for that. But another way that it has impact is that it has time-sensitive data, which most other calculators out there do not. So there are plenty of existing solar calculators, but they all use an average and don't take into account the variations over day or year. It can also be used for the space industry and space exploration because of the instruments on the satellites that use electricity and rely completely on solar. So we have a few factors that we've looked at so far, but there are a few that we'd actually like to pursue if we were to continue this further to make our predictions more accurate. And in the coming years, we'd like to include wind power as well to create interactive maps that show the renewable energy load that these renewable sources could actually carry, and as well combine policy incentives for renewable energy like subsidies and things like that. Finally, we can use it to budget energy use for for satellites and for households or factories. So, thank you very much.
Cool. Give him a round of applause. Sorry I made you laugh. It's how I get attention for myself. Judges, if we could get 2 minutes of questions now.
Thanks for your presentation. That was great. Maybe the gears are just turning in my head, and I'm not quite sure if you'd address this in terms of future thinking and its application. So it looks like peak generation is during the middle of the day, and we're not using our appliances at that time. And I instantly went to like an Internet of Things solution in terms of let's turn on our appliances during that time. We're not there. We're not home. We're at work. So have you kind of gone that next step in terms of how are you going to bridge that disconnect between this is when you need to use things, but we're not home to do that?
Yeah, so we did look at that actually. So one of the things that wasn't really displayed very well there, but we did include was the rates at different times. And so during weekends, for example, it's actually at off-peak rates. So in the middle of the day on weekends, you're actually generating peak power, even though the rate is low. Also, one of the more exciting future potential opportunities for this is that with an increase in automation, we won't need to be around for certain processes. So you can actually optimize your energy uses to continue automated processes with or without human interaction. So you could get to the point where you don't even need to change your behavior or look at the data, it just does it for you. So that's the end game, I guess. So, yeah.
Cool. Perfect. Let's give him a big round of applause. Now, last and certainly not least, we have the Yes I Can team coming up. I meant to say something, and now I can't remember what I was going to say. For those of you for the People's Choice, when you do see the link after the presentations are done, please feel free to visit that form, fill it out, let us know which solution, which team you think should win the People's Choice. If you don't remember one of the teams that are listed there, or you don't remember what one of the teams that you liked was called, you can go to spaceappschallenge.org. You can go to the Toronto location, and you'll be able to see all the teams at the bottom of the page. You'll be able to find the one that you were looking for. All right, and now give a big, warm welcome to the Yes I Can team.
Hello, my name's Arushi. The name of my project is Yes I Can. On Friday, when the Canadian astronaut was presenting, I heard him say that if you switch off space for 10 minutes, you have a big problem. So I thought, what kind of problems will we have? So I went to the Toronto Reference Library and took an image from the Canadian satellite. And then I cut it into lots of pieces. If you do not believe me, look at this video. But after, we also joined them together to make lots of different forms. Space makes our phones work. Space makes the GPS work. Space brings together Canada. Space makes us Canadian. Now let's celebrate the 150th year of Canada. Thank you.
Do the judges have any questions or comments?
Thank you. I just find this very creative. And so the colors that you're using there, this is from a RadarSat image.
Yeah.
And then you didn't change any of the colors, right?
No.
And you're using it to recreate new images. So what was you have the inspiration from Jeremy. Where do you think you're going to go next in terms of what objects do you want to make?
We tried to make lots of images using the Mosaic software.
In fact, we tried to make Jeremy Hansen, but we didn't have enough images from the Canadian satellite. So we were actually lacking data from the Canadian satellite.
Fantastic.
Any other comments or questions from the judges? All right, let's give her a big round of applause. Ladies and gentlemen, we are now through the presentations. Give all of yourselves a round of applause. Now we will direct you to go to tiny.cc/spaceappsto. At that link, you will find a form. Please fill it out with who you think deserves to get the People's Choice for NASA award. In the meantime, what is going to happen, food will eventually arrive. It is a little bit late right now. I'm going to take the judges to a super secret place that none of you know about, meaning the boardroom right in front of you. And we will deliberate and talk about you guys behind your backs to determine the two NASA nominees, the one CSA nominee, and the Dot Space nominee. I would like, because we didn't, because we had issues with the Dot Space domain name, if I could get one representative from every team that was using the Dot Space domain name to come to me, I'm standing right here. I will just mark you down just to make sure that we enter you in. Even if you didn't get a chance to actually get access because we had issues, we'll make sure that we include you in that. All right. Otherwise, we will talk to you in a little bit. Stay tuned, hang out, grab a drink, and we'll be back shortly. Thank you.